Hey future programmers, got an exam coming up? Need a quick recap of multi-threading? Well, you're in luck. In the next few minutes, we are going to dive into the essential concepts of multi-threading in Java, and I'm going to make it super easy for you. Let's go. Introduction to multi-threading. First things first, what exactly is multi-threading? In simple terms, multi-threading allows a program to perform multiple tasks simultaneously. Imagine you're cooking dinner and at the same time you're listening to music and chatting with friends. Multi-threading lets your computer to do the same with tasks. Instead of running just one task at a time, multiple threads run in parallel, making the program more efficient. Alright, now let's talk about creating threads. There are two main ways to create a thread in Java. First, by extending the thread class. You create a new class that extends thread and override its run method. Once that's done, you create an instance of the class and call start method. Here's an example. Let's break it down into simpler steps. Create a new class. You create a new class that inherits from the thread class. This means your new class will have all the abilities of a thread, but you can also add your own special behavior. Override the run method. Inside your new class, you write a special method called run method. This is where you define what the thread will actually do when it starts running. For example, printing something, performing calculations, etc. Next, create an instance of your class. After creating the class, you create an object, an instance of that class. This object represents a thread. Next, call start method. Finally, you call the start method on the object you just created. This tells the program to start the thread and automatically call the run method you wrote. Second, by implementing the runnable interface. Instead of extending the thread class, you create a class that implements the runnable interface. The runnable interface just requires you to write a run method, which defines what the thread will do. Next, override the run method. Inside your class, you override the run method. This is where you put the code that you want the thread to execute. Next, create a thread object. After creating the runnable instance, you create a thread object and pass the runnable instance to it. Next, call start method on the thread. Now that you have a thread object, you call the start method on it. This starts the thread and automatically calls the run method. The advantage of using runnable is that it allows your class to extend another class, since Java only allows single inheritance. Now let's understand the life cycle of a thread. Think of a thread like a job at a company. It has various stages. First, new. When a thread is created but hasn't started yet, it is the new state. Runnable. When the thread is ready to run, it enters the runnable state. The thread is in the queue waiting to be executed by the CPU. Blocked. If the thread is waiting for the resources like input-output, it enters the blocked state. Waiting. When a thread is waiting for another thread to perform a particular action, it enters the waiting state. Next, terminated. Once the thread has completed its execution, it enters the terminated state. It's like a cycle. Thread starts, runs, waits for resources, and eventually finishes its job. Next, let's talk about the thread priority. Just like people, threads have priority levels. The priority determines the order in which threads are scheduled by the CPU. In Java, priorities range from 1, that is lowest, to 10, highest. You can set thread priorities using the set priority method. For example, by default, all threads have normal priority, but you can adjust them if you want to give one thread more importance over the others. Let's move on to executing a thread application. Once you create a thread using either the thread class or the runnable interface, you execute the thread using the start method. The start method calls the run method internally, kicking off the execution of the thread. When you call start method, the thread will run in parallel with the main program. Remember, do not call run directly. Always use start to begin the thread. Finally, let's talk about synchronization and inter-thread communication. It is the trickiest part, but we'll make it simple. Synchronization. If the simple thread are accessing shared resources, it can cause data inconsistency. To prevent this, you used synchronized blocks to make sure that only one thread can access the resource at a time. Inter-thread communication. Sometimes threads need to communicate with each other. This is done using methods like wait, notify, and notify all to control the flow of execution between the threads. For example, wait method makes the current thread wait until another thread signals it. Notify method wakes up a thread that's waiting. Notify all method wakes up all threads that are waiting. This is super important when threads need to collaborate on shared resources. Alright, let's quickly recap everything. Multi-threading allows multiple tasks to run in parallel, boosting efficiency. You can create threads by either extending the thread class or implementing the runnable interface. The lifecycle of a thread includes states like new, runnable, blocked, and terminated. Thread priority helps you control the execution order of threads. You execute a thread by calling the start method. Synchronization ensures thread safety when sharing resources, and inter-thread communication helps threads cooperate. Hey everyone, our free advanced Java course is launching soon on Udemy. Here's what you'll get: practice test, interview prep tips, quizzes, and assignments to help you build a standout portfolio. Ready to level up your Java skills? Find the link in the description below and enroll for free. Boom! That's your multi-threading crash course. Quick, simple, and packed with everything you need to know. If you like this video, don't forget to hit that like button, subscribe for more, and drop any questions in the comment below. Good luck with your exams.